For today's session, topic of the session is Git Mastery Session now. Today you all will be enlightened about version control, Git, GitHub, setting up, creating and using a new repo, create on GitHub, clone, add, commit and traceback commits. Now on to the speaker of the session. Today's speaker is an accomplished instructor from the Department of Computer Engineering, University of Peradeniya. Specializing in computer engineering, they have significantly contributed to the advancing of department's digital presence. Notably, they have helped establish the CE/PD and ACLK GitHub organization, co-created the projects.ce.pdn.ac.lk platform, and serve as the admin and coordinator for all Peracom sites. Please join me in welcoming Mr. Akhila Karunanayak. Let's get started with the session.
Hello. Is this the part where I start? Or
You can carry on.
okay. Can you guys hear me?
It's a revenue.
Okay. Right. Thank you for that wonderful introduction. Yeah, I'll just get straight to it. So yeah, I am Akhila. I am an instructor at the Department of Computer Engineering. Anyways, today in this session, what we are going to be looking at is some of the basics of Git and GitHub. So this is a two-part series. In the first session, we'll be looking at things like version control, like what version control is, and looking at Git, GitHub, and how they come into play when it comes to version control. And then I'll be giving you a few tips on setting up, and then we'll be looking into doing the actual work of like creating a project, creating a new repo, how you can put it all into GitHub, and how to use Git as a tool to keep your files in check. Okay. And of course, if you have any questions during the session, please feel free to unmute your mic and ask a question. Let's see if I can see the chat. Yeah. By the way, you can see my screen, right? I just stopped sharing, but okay. You guys can see my screen, right?
Yes, sir, you can.
Hello.
Yeah.
Okay. Yeah. So as I said, please feel free to unmute your mic and ask me questions or put them in the chat. Okay. So when you look up Git on the internet, it comes up as a free and open source distributed version control software. I know, big words. So free means it's free, so you don't have to pay anything to use it. Open source means the source code is freely available. It's freely available for us to just go and look at it, or even just to contribute as a contributor. And distributed is an important keyword here. Distributed means that you can have the same code synced up in different places. So this is very important when you're working in teams. So in your team, when you're working on the same project, you have to have the same set of codes or same set of files at each of the members' local setups. So that is possible through Git. And then one of the key things in Git is version control. So I'll get to it in just a few slides. Just let's put a pin on version control. But how did Git actually come about? So I don't know whether you guys have heard of this guy, but Linus Torvalds founded it in 2005 for the Linux kernel development. So If you don't know who this is Linus Torvalds, and he is the creator of the Linux kernel. And he did this way back in around 1991 when he was a uni student. But when it was around 2000s, early 2000s, a lot of people started using Linux as a system, as a software, as an OS. So right now, as you can see, each of the Linux distributions that you have heard of, be it Ubuntu, Fedora, Mint, Debian, or whatever, all are based on the same Linux kernel. So when 2005, 2004, 5 came around, it was apparent that the Linux kernel was growing in size. So this Linux kernel is also one of these free and open source things. So anyone in the world can go and contribute to the Linux kernel, and maintaining all these changes, all these feature updates to the Linux kernel itself became a very big problem when it come around these times. So what he did was create Git as a tool. And what this allows us to do is to keep track of the changes in the project and figure out what the changes are, when the changes happened, and who did the changes. Yeah, so just stepping back a little bit, I'll just start from you guys' day-to-day work, right? So either you're from elec, com, or whatever, you're from engineering anyways. So in day-to-day tasks, when you're working on some project, what do? You either create files in the sense you create text files, doc files, whatever. And you do edits on the created files. And after you do the edits, you would do a save. So this is where things get tricky. When it comes to save, like when do we really save? So we do saves when there's file changes. So if we add a line or delete a line or update a keyword in some of the code, we do a save. So what do we really do when we want to keep track of these saves? Some of the more like software engineering based practices is to comment. So you would try your very best to comment about what the changes have been done or what the set of code does. Or I have seen this quite often where people start saving different files. So if you start off with a file named test.py and you would do some change and you would save the second file as test1.py and the next file goes test2.py. So why do we really keep different files in the end? The reason is, as we all know, if test1 or test2.py implementation does not work, we need to find a way to go back to our previous code, sort of a previous checkpoint, or in gaming terms, a previous save point that you could restart or rebuild your code in. So when we are trying to do this multiple saves meaning test1, test2, test3.py saves, it is okay when it's just simple single file codes or whatever. But when it projects, so when it comes to, let's say, a third year project, fourth year project, and you're working with a lot of code, a lot of files, a lot of folders, this gets messy. It gets real messy in the long run. So another thing that we can handle using Git and GitHub is the team collaboration part, as I said earlier. So when you have your Fred, Dave, and Lisa working on the same piece of code, and if something goes wrong or in the development of the project, you need to keep track of when those changes happened, why those changes happened, or why those changes occurred, and what those changes are, and who did those changes. Because I know quite often we will come to a point where we need this information, where everything starts to fail, and we need to figure out how to fix the code. But most importantly, we also need to put all these different changes together, which is called merging in Git terms. So we need a way to successfully merge all these changes. So few characteristics in Git. So Git is not the only version control software out there, but it is by far the most popular one. So Git can run locally without a server setup. So in any of your machines, you can have Git installed and work with Git locally and just keep it all your files and all these version control stuff locally. And it is fast. It is written in C++, which is kind of a lower level language, which is known for its efficiency. And we can keep changes of the history. History meaning the what, when, why, who. And also we can do collaborative changes where multiple people can work and do changes on the same piece of code. And it has easy to use, but very powerful commands. So I will take you through some examples, some of the basic commands, and they will appear to be very simple, but they are very powerful when we are working with these kinds of large projects. So my general advice to anyone who's starting with obviously anything is to start with the minimum subset. So the minimum commands that you want, and then learn as you go. Just slowly, little by little, increase the command pool that you have, um, that you use. Yeah, so I also have to make this a point. So Git and GitHub are two different things. So Git is the tool that runs in your local machine. And yeah, it is the underlying tool, but GitHub is more of the hosting platform. It's something where we can upload our code to it. And it's where it's a hosting platform that we can use for collaboration. So the code is available for all your teammates or your project members to use. So yeah, are there any questions so far? Because I'll be giving you a few tips on getting started, but yeah, please feel free to ask any questions so far. I'm checking the chat. Nothing there. Yeah. Okay, if there's nothing else, yeah. So one of the most like straightforward way to get started using Git and GitHub is to first go ahead and create yourself an account on GitHub. So that's fairly straightforward. You can just go on to github.com and yeah, you can just click on sign up and create your account there. So when creating, you can have your personal email. That's totally fine. But I do have to mention, if you have an ENG email, you can use that or add your ENG email as a secondary email, because when you do that, you will get access to the student education pack through because you are using the ENG email. The student developer pack will allow you to, let's let it load. It will allow you to do use some pro versions of tools, things like JetBrains or Notion, and it will give you some credits on Namecheap to have your own domain. Or I believe there's some server hosting platforms that are available. So please check it out. So when you are creating an account, you can have your personal email, but add your ENG email as a secondary email, so you can get the benefits out of GitHub Student Developer Pack. I'll just put put everything in the chat. Okay. Right. So once you have a GitHub account, it will look something like this. Now, obviously, I have a few projects in my repository, in my profile, but yeah, you can have your page, your front page profile looking something like this, where you will have your repositories or the projects that you keep track of. And yeah, this is basically what it would look like. Why is interest of okay. But my profile is very basic. It's like one of the minimal things that you can do. But if you go to people like Ridma, who is also instructor at the university, he has a bit of an introduction to his profile, and then he has the pinned ones and his commit information. Or you could take a step further and make it look something like Dindra. He has his Stack Overflow stats, and he also has his most commonly used languages in the GitHub. Yeah, or you could take it much more further. Nuanjaligadu, who is from E15, and make your whole GitHub contributions look like Snake. Yeah, so the possibilities are endless, but I don't know. This is something that you can work on at your own time. I'm not going to get into how to beautify your GitHub profiles, but this is something that you can genuinely show when you are going for your interviews to show the work you've done, the projects you've done. And of course, even this page itself would show how much of a creative person you are. Yeah, so that's it for GitHub profiles, but I'll be focusing on my one for now. Yeah, so once you create a GitHub account, you will have a profile, and it will allow you to create repositories in GitHub. So again, GitHub is the cloud platform that we're using to host our code, but we have to get them to our local machines to work on. So to do that, developer package here. So yeah, you could have things like JetBrains, Namecheap domains, GitHub Copilot, Notion, DigitalOcean's platform, Microsoft Azure. Yeah, you can have a lot of stuff through adding ENG email to your GitHub account. Yeah. Yeah. So when we are using GitHub, we also need to use Git in the Git, which is the tool. So what you can do is install it. So it's available on all platforms. For Windows, you can use its own Git bash, or you can also use your PowerShell. All things work cross-platform. For today's demonstrations, I'll be using Linux, and I'll be using the CLI commands itself. The commands are general for everywhere, so you can use the commands on any of the platforms. There are also instances where people use the VS Code extension for GitHub, which adds GUI elements to do Git actions. I am not going to use it today, but keep in mind, either way, when you're using those UI tools to commit, push, pull, whatever, underlying in the background, they'll be running the CLI commands. So I'll be sticking to the very basic CLI command, so you can have a first-hand look at what's actually going under the hood. Yeah. Yeah. So installing GitHub, you can do it pretty easily. Installing Git, you can do it pretty easily. Also, you can have this reference for all the possible commands using Git. And I would highly encourage you to have a look at this cheat sheet, because this sort of concatenates some of the most useful commands and the most frequently used commands when you're using Git. Yeah, this presentation, I believe, will be shared. So the links are all here. Yeah, so that's setting up GitHub, setting up your GitHub account and installing Git. Once you do all that, you would have 5 more steps to do. I am not going to demo these here because I've already set it up on my machine. But what this essentially does is sort of figure out a ways like to verify your local machine with the GitHub profile that you have here. Previously, a while back, we could use the username and password when we're interacting with GitHub itself. But now they have sort of made it mandatory to have SSH keys. You don't have to think much about it. It's just generally generating a private and a public key, and then pasting the public key in GitHub, and you keeping your private key, and that will be the sort of validation that GitHub needs to validate that your local user is actually the profile, matching your profile to your local machine. Yeah, so I'll have these here, and this is sort of for each of the OSs, so Windows, Linux, Mac. Yeah, setting up your SSH keys, all documentation here. Link is in the slide. Okay, so once you have all this done, that's when we start working with GitHub. Yeah, before demoing, like the basics, are there any questions? Please feel free to put them in the chat or unmute your mic. I am audible, aren't I? Yes. Okay. Anyone? If not, I will be going ahead with the demo. Okay. Right. So when we are, I'm just going to close this, and I'm going to bring up my terminal. When we are going to start sort of a project and it requires version control, there's two ways to do it. Let me bring back. Okay, I'll be taking notes here and I'll try to draw stuff here. Okay. Okay. So when we are trying to create sort of a project and it requires version control, there's two ways in creating your project with Git. One is creating your project locally and initiating Git and going on from there, like make the project first in locally and then put it onto GitHub. Or you could also create the project in the remote GitHub and then get it to your local machine. The easiest way is the second one. So creating a project in GitHub, that's what we'll be doing. If you want, I can show you the other way as well. So to start something, a start project, you would go, so once you create a account, you will be at the overview section. You would go to your repositories, and then you would start by clicking this new button. And yeah, choose your account. So you don't really have to think much about it, about this, because this is there because I'm part of different organizations. Right now, I want to create my repository in my own personal profile. So I'm selecting my account. And then I can give a repository name, something like Git Session 1. And then give a description. This is the GitHub session day 1. And then you will be given the option to make it public. So anyone on the internet can see your created repository, or you can make it private. When you make it private, it's sort of personal repository that only you can see. In this case, I'm going to go with public. And then you can also add a README file. So most of the time, GitHub likes to use the MD format. README.md is MD file formatted README file, which gives you sort of a long description about the project. And there are many ways you can provide descriptions with icons, emojis, anything. So I'm going to allow it. I'll come back to Git-ignore in the end. Yeah, so that's like the basic settings. You can go ahead and create a repository. And once you do that, you will have your first repository on GitHub. So these are the things we gave. So Git session 1, the title. This is the GitHub session day 1, the description we provided, and it will be automatically added to the README file as well. Yeah. Now, what we have is on the remote GitHub hosting platform, we have created a project that has Git. Now, what we want to do is get this into our local machine. Before doing that, I would like to introduce you to a thing called commit. So commit is something like the checkpoints I mentioned earlier, sort of like the save points. So each of these commits saves some sort of a version of your code or your project. Right now, it has the initial commit. This is done by default through GitHub. So at the initial commit, it will have things like this. So at the initial commit, when we are creating the repository in GitHub itself, we added this line was automatically added to the README file, and the README file was created. So that is essentially the first sort of checkpoint or save point, or in Git terms, I will call it a commit. So they have all by default, they may name it initial commit. So when we go back, we can see right now we have only one sort of save point, and it's called initial commit, which has the readme.md file. Now, if I go to my, okay, let's try to make it sort of easier. These circles will be sort of save points. So we'll call this initial commit. Let's make this bigger. So initial commit, and this happened on the remote GitHub. So for now, I'll call it remote. And yeah, so initial commit at the remote repository at GitHub. And you could also see something here. I will I'll go into detail, I'm thinking, in the second session, but right now, all you have to know is there's a thing called branches. So branches like a tree in version control. Whatever happens, you start at the main branch, so sort of like the tree trunk. So right now we have only one branch, which is called the main. So in here, I'll name this sort of as, okay, maybe I'll main. Okay. I hope this is clear so far. If you have any questions, please ask away. Yeah. So what information do we have here? We know we are in the remote repository, which is GitHub, and we are in the main branch, and we already have one save point called an initial commit. They have named it initial commit, so I'll keep it here. Now, this is all remote. It's not on the local machine. So in the local machine, I can go to documents, and I have created a folder called GitHub Sessions. Currently, there's nothing in it. So what I want to do is get this repository called Git session number 1 in here. To do that, we would give a command thing called git clone and the URL. Now, in here, this is where that password protected SSH key comes into play. You don't have to do anything if you set it up. You can just simply copy the URL and go to your terminal and just paste it. So what will happen now is it will clone or copy all the code in this Git hub. And okay, we cannot see the shared screen. Guys, you got to tell me before. Okay. Yeah. Can you see it now? Okay. How far have, like, when did you stop seeing the screen? Because I can quickly run through.
We could see the screen. Yeah.
What one?
We could see the screen throughout the session so far.
Okay. Okay. What was the cannot see the shared screen thing? So right now you can see the screen, right?
So we can.
You can, right?
Yeah.
Okay. 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 Then I'll continue. Just please let me know if the screen doesn't like share. Okay. So the first command is git clone and the URL. So yeah, SSH, you used SSH key to verify that your local machine is linked up to your GitHub profile. So you can straight away go and say git clone the URL, and you can just press enter. And what this will do is it will create a directory called git session number 1. If you go in there, you would see the README file. Okay, so I can quickly go to my notes and I'm just going to add, okay, maybe I'm just going to add things that we learned. The remote to local, copy repo. Okay. So to make it clear, I might open this in VS Code. Right. In VS Code, we can see we have our README file. So if you want to have a nicer look, this is it. So what have we done? We have taken this remote repository and cloned it locally. So copied all these files locally. So now we have our own version in our local computer. So if I go back to the diagram, this is what has happened. We have created our local version, right? So this is the remote repository that is on GitHub. And now through git clone, we have taken into our local. So if we go and check, so another command I'm going to introduce now is called git status. So what this will do is simply give you the current status of your Git repository. So once you click that, it will give you a message called on branch main. So as I mentioned I mentioned before, so main is sort of the main branch or like the tree trunk part of the repository or the history of the changes. So we are on branch main. That's done. Because remote was on main, local is also on main. Your branch is up to date with origin/main. So what this means is origin is sort of a keyword that Git uses to refer to the remote repository. So this origin is simply the remote repository URL. So instead of calling it remote, Git calls it origin. That's the only thing. So what it says here is we are currently on branch main. So in the local, we are on branch main. Your branch is up to date with origin/main, meaning your remote repository is main. So both things are up to date. Nothing to commit, we're going to clean. We'll get to that later. So this sort of the second thing we've noticed, git status, which is checking the status. Right, now, so far, we have created our first repository in GitHub, and then we have cloned it, meaning we have copied them to our local machine. And now we are both the same, like same level, like we have the same codes in remote and local. Now we are going to have a look at the checkpoints. So one of the key things, as you remember, I keep on telling on Git, in using Git, is having these checkpoints or save points of our previous work. So we can have a look by looking at the command, by using the command git log. So when we type in git log, it gives us the information. So what does this say? This is me. And on 25th, 8:30, I made the initial commit. So this initial commit was made on the GitHub remote repository itself. And each of these commits has its own sort of SHA, like a hash, to identify what the commit is. And what this says is the head is on main. Okay, I keep introducing you to these keywords little by little, but please try to bear with me. So this says the head is at main. This means is our code, our local project version is at main. So what this means is our head is at main, right? We are here. That's what it says. And this also gives us the information saying origin is at main, origin main, meaning the main branch of the remote repository. And that's where the origin head is. So this guy is also here. In the remote repository, that's the latest version. In the local repository, that's the latest version. Okay, so now we will already learned the commands. Git log to check commit history. Okay. So quickly going back, we created our project and we cloned it, meaning we copied it to our local machine through git clone. And then we checked the git status. Did I miss git status, git clone, and git log, meaning the commit history. Now, how can I? Now the question is, how can I sort of make use of this checkouts or this git log or the commit history? If I go back to our Visual Studio Code, let's sort of edit the README file. I'll say, hey, this is hello from the local repo and save. Okay. Now, the command to use here is to see the state. So I already changed a line in the README files. So I would like to check, like, what's the status of this Git repo. So I would type in Git status. And now it says something. It says changes not staged for commit. Okay. Staged is another keyword. I'll get back to it, but changes not staged for commit shows in red saying this readme.md is modified. So when we are creating these save points or commits, we can include what information to be included into that commit. So for instance, in this initial commit, what did we see? We saw that there's information. This initial commit, all it did was so what did it do? It said it created a readme and it added a single line. So this is what happened at the initial commit, at the initial save point. This is what was saved. So right now we are here, and now we have made a change. We have made a change in the README file. So right now we are in the process of creating the next save point, right? It's a blank state. It's a blank checkpoint. Now we are trying to figure out what needs to be saved, what needs to be included in the save point. So I can also do something like, okay, we'll keep it simple. Yeah. Okay. So right now we have this README that's updated. So to add this information, to add this extra line that I added to the next commit, I would have to bring it to the staging, like make it staged. So what it means to be staged is to be included in the next commit. So I could simply type git add readme.md. Now when we check git status, it shows changes to be committed. This is in green, right? So now we have added this to the stage. Like now we have our own thing saying added line to readme. This is it's the staged state. So I can maybe call this stage, maybe. Okay. Right. So if you want to unstage something, like if you later on figure out, okay, maybe I don't want to include this in the commit, we can go and use this command like restore staged and readme.md. Now let's check status. It's back to red again. So another thing that you can do, you can either specify git add by the file name, or you can do a dot signifying all the files that have been changed. Okay. So, and we can status and shows it's staged again. Now new command we learned, git add files to the commit, or we call it staging. Okay, right now we have staged the README file. Next thing is to create a commit, create a save point. Now we can say git commit -m for the message. So earlier, this message was done by default, calling it initial commit. We can add a commit message here saying, let's say something like local add readme update. That's simple. Update with one line. Okay. There are conventions to do the Git messages. I'm just going to keep it very simple so that you guys can understand. But yeah. And we have created a commit. And now let's check the status. What does it say? Your branch is ahead of origin main. Remember origin main? Origin means remote, main means the main branch. By one commit. So we have already created this. So this is the README. Now I regret having a long name. Update. Let's say README update. With one line. Local. So that's the Git, like the commit message we have. And this is the file. This is the change that we did. And now we can see that our local main or local repo is one commit ahead of the remote. And if you go and check git log, we can see now our head is at main, but it's at the new commit status. So we can go ahead and move our head here. Okay. So the remote head is here. Remote recent commit is at the initial commit, but locally you add a new commit. So Did I do? Okay, git, can say git commit, create commit with staged files. Okay, so seems simple enough. Okay. Now, what do we want to do? Now we want to send these changes back to the remote repository. So to do that, we would go and use the command git push. That's it. Once you have, like, if you check the git status and you only see this message saying that, okay, there's commits that are in the local branch, local repository that needs to be committed to the remote branch, you can simply go ahead and say git push and then type it in. Yes, and they will be sent. So if you check back git status, it says you're up to date with the origin branch. But more importantly, we can go back to our repository and it's still at initial commit with one commit. We can refresh this and see, now we have two commits with the extra line. Okay. So now we have updated the commits in the remote repository as well. And this is the I don't know, big git commit message I have given. So if you go like into the commit details, you would see that we have added. So this plus and green means we have added this line. That's the change. Okay. So now we have created a repo here, cloned it, copied it to local, did our changes, and pushed it to the remote repository. Okay. So now we know how to like keep it hosted. But now, let's say one of your friends did a change here. I am not going to go into pull requests right now. I'm thinking of doing it in the second session, but let's say as an example, someone did a change here. So saying, hey, this is hello from the remote repo. And you can just commit changes and remote update. And commit. So this is not really sort of, I don't know, it's your preference editing your files here in the GitHub itself. I don't know, I'm not really comfortable using it, but you can give it a try. Because so if you are in GitHub and if you press the full stop, the period button, it will change into VS Code dev environment. So I'm guessing the people behind GitHub really wants us to use it. But the thing is, it's a bit slow and I don't know, it's not really intuitive. For now, I just simply quickly edited the remote repository and committed and created a new checkpoint. So remote update. So we'll update this saying, okay, we have this is stated and added readme. This is what happened when we did the git push, but now we have created a new one saying, what did we say? Remote update. So remote update. And we did was again added a line to readme. So maybe specify it from remote. And our head is at here because that's the most recent change. Maybe. So now we can see the changes. Okay. So this is where we at. At the remote repository, we can see that we had this remote update commit. It's 3 commits in, but locally, if we stay, if we look at the git log, we are still at the one line that we added locally. Now, if we check Git status, it still thinks we are up to date. The thing is, it doesn't automatically detect that changes have happened in the remote repository. What we can do is a simple command called git pull to get all the changes in the remote repository, like after the final commit from local repository, if changes have been done in the remote repository. So this is an example where your friends have made, or friends or teammates or project members have done changes in the remote repository, and you want to get those new changes into your local repo. So you can simply type in git pull. Now, when we do this, you will get a message, if I'm correct. Okay, we don't get it. Yeah, so now all the changes in the remote repository should be available in the local repository. So if I go to VS Code, there's the line. Hey, this is a hello from the remote repository. So to make sure, we can have a look at git log, and voila, we see that our head has changed to the main. Yeah, we can copy this. We have the exact same thing. And our head has moved here. So right now, I have covered everything about creating a repository and having it locally and doing the changes. So doing local changes and pushing it to a remote repository, and getting changes in the remote repository to your local push pull repo get remote repo. Okay. So these are the very basics. Yeah, so these are the commands I've done. So git add, git commit. So git add adds your stuff to the staging area. Git commit creates a commit. Git push sends your commit to the remote repository, as we have seen. So git fetch is another command. But doing git fetch and git merge, what it would do is get the commits to your local repository, but it won't add it to your working directory. So to do edit, we would have to give another command called git merge. But without doing those two commands, we can straight away say git pull. That's what I did. Yeah, so these are the very basics of creating your, like, maintaining your own project. Yeah, so till how are we doing on time? And do anyone have any questions?
Yeah, then we can have the Q&A session.
What was
Hello?
that? Oh, yeah,
Then we can have the Q&A session.
we can have a Q&A, yes. Please, if you have any questions, please ask. Yeah, sure, you can get the presentation. I'll share. So, okay, if you have a bit more time, I can also show you something fun. When we have this setup, now I have done the basics, right? Creating a repo, putting it to remote, like creating a remote repository, getting it locally, and then you have synced it. But I also mentioned the checkpoints. Why are we using checkpoints? So we can use, I have to change it to commits now. So why are we using commits? We use commits to go back and forth from our previous save points. So imagine right now, right now, we don't have to imagine, we are here, right? We are at the final update that we got. So if you look at the Git log, it shows we are here, where we did the remote update, where we added this final line. let's say we want to go to the stage where the line was added from the local repo. So how can we go to that place? So this is what you do. When you have did I stop share? All right. Okay. So when we have all these commits, we have to find a way to go back. So what you can do is give a command called git checkout, meaning you can move to a previous committed stage. So I want you guys to keep an eye on our code here. I want to go to the stage where we didn't have this line. That is essentially this commit right here. To do it, we can simply copy the first few numbers. It's like 5 or 6 numbers. You can copy and say git checkout, go here. And what happened, right? These lines disappeared. The lines that were from the remote repository well, disappeared, and we are now at this checkpoint. If I type in git log, would it show? Yeah, git log only shows where we added this commit. So, okay, there are a few chats here, right? Okay, I'll get to the branching and all the rebase stuff. So this is how we can go back. So I am thinking of doing it in the next session because I believe we might be running out of time. So branching that's when we need branching. So here, what did we do? So I will go back. So we can go back to our main by saying git checkout main, because it will be all there. So if you look at git log, we will see the most recent change. So let's say I want to go back here and do some other change that I want to test out. I don't know whether it will work as well as remote update, but I want to keep working on something else other than remote update and see how it goes. So that's where we would create a branch. So in this case, what I first have to do is go to this place go to this commit right here. So we can do it by using git checkout and here. And now we can create a branch here. So we can say branch -b, I believe we can say feature. Okay, maybe I made a mistake. I can just put the name. Okay, now, okay. And if I go check out feature, git status, git log, that's what we have. So this is what I did. I was initially here where we are at the current most recent update. But I want to go here and try out something new other than the remote update thing. So I would first take my head from here to here. So that's what I did by using git checkout and this hash number, right? So once I did that, I am at this place. So when I say git status, it would show head detached at this place. Then I would like to create a new branch out of this place. A new branch meaning a new pathway that I can work on other than this remote update. So that is what I did by calling git branch feature, which means I would create another branch. Okay, another branch from this starting point. So I would maybe have empty commit here. And I would say something like go here, right? So this is the branch thing. This is the main part. This is the main branch. But now we have this other branch called feature. Okay. So what happens is now, once I created a feature, it creates, once I created a branch named feature, it creates a branch out of the, out of where I am at. So at that point, my head was here. So the branch will create it out of this commit. So that's why when I go and say git checkout feature, so go and switch to the branch and say git log, check the commit history, it only shows the one line, and the initial commit only shows these two commits, right? So right now we are at this point. Now we can do changes here and carry on our work. And then once we are satisfied, we can add these new saves, new checkpoints to the main branch. So that's like the most. Yeah. So we can just add this here. Okay. Yeah, so that's where our branch is coming. One of the instances where branch is coming. So when we are having this remote update and we want to work on something else, we can create a branch and keep working on it. And if this works, if this feature branch works best, or it's the new update, we can do something called a merge or a rebase. So there are two things. So I believe one guy asked, what is Git rebase? So two different ways to add this branch to the main. One is merge and other is rebase. What merge does is it sort of keeps track of all the changes that have been done. So meaning it'll keep this change as well, remote update change as well. And it will also keep all the changes that I did along the way in the feature branch. And then it will try to merge the changes. Merge meaning like putting them together, right? But when it comes to rebase, what it does is it tries to clean this out. So it tries to remove this remove update thing and sort of replace it. So it looks like we've been working on the feature branch all along, right? That's the difference between merge and rebase. But the problem is rebase would result in a very clean commit history, because you won't like keep the record of the unnecessary remote update here. You'd only have the necessary feature commits. But we have to be careful in using rebase, because there are some instances where rebase can't really be used. Still to this day, most people would prefer using merge because it's sort of a safer option. There are instances where rebase can be used. Yeah, I will get into more detail on the next session on rebase. Yeah, because next session I'm planning to do how, when we are actually working with multiple people, how we can sort of merge stuff and rebase stuff. What is referred to as a branch in Git. So this is that. So when we have even main is called a branch. And when we come to the second commit, we divided it into this feature branch. That's why it's called branches. It divides. And in the end, once we are satisfied, we can add this branch, sort of merge these branches together. Are there any conventions on commit messages, any technical terms or key phrases we use so that anyone checking the repo can understand? Yes. So right now, I just made I just add commit messages so everyone can understand. But generally, the sort of rule of thumb is sort of add commit messages by saying something like this, like this commit will do, and have the blanks. Okay, so this blank will be the commit message. So let's say this commit will maybe do isn't needed. This commit will update the readme, right? So and create a new function. Okay, so this will be sort of the rule of thumb in commit messages. But obviously different organizations, like different companies, if you have to work with them, they have different standards in commit messages. But this is sort of the general scheme we can see. Yeah. Any other questions? Also, something fun to check at, if you are interested, Linux commit history. And as I said, it's free and open source. You can see everything there. And yeah, the man is still working. 13 hours ago, he has merged changes to the Linux kernel itself. And yep, this is the guy I mentioned. Yeah, so if you're interested in contributing to the Linux kernel, you can do that as well, because the whole source code for the Linux kernel is right here. Okay. Any more questions? If not, we can wrap up. Okay, guys, then that's it from my side.
You, Mr. I extend a heartfelt gratitude to all who made this event a success. Firstly, I would like to thank our esteemed speakers for sharing their invaluable insights and gracing us with their presence. Your words are truly inspiring. A big thank you to the organizers, volunteers, and everyone behind the scenes who worked tirelessly to make this event seamless. To our attendees, your presence and participation mean the world to us. Thank you for your time and support. Lastly, let us continue to carry forward the spirit of this event in our endeavors ahead. See you all with GitHub Mastery Session 2. Thank you all and have a great day.
Thank you all.